Here we're discussing the solutions for numbers 8, 9, and 10. And definitely we have to use the sum or difference formulas for these problems. So here you're told that angle X lies in quadrant 2 and angle Y lies in quadrant 1. So we're going to draw two separate coordinate planes and draw the proper triangles. So this is going to be 21 and 29. And this right here is going to be 15 on the x-axis because it's adjacent to our hypotenuse, and 17 for the hypotenuse. If you do Pythagorean theorem, you should get 8 for the vertical side for angle Y. And for this one, a little hard to do in my head, so I'm going to use a calculator. 29 squared minus 21 squared. Yeah, you should get 20. Now, but negative 20, because it is pointing to the left. So when you want sine x minus y, you're going to do sine x times cosine y minus cosine x times sine y. Well, sine x we know is 21 over 29. Cosine y we know is 15 over 17. Now cosine x is negative 20 over 29, and sine y is going to be 8 over 17. And you have a minus negative, so it comes a positive. So you're doing 21 times 15, which is 315 plus 160 all over whatever 29 times 17 is, which is 493. So you get 475 or 493. I know it's a weird number, but that's our answer. And by the way, this should never be more than 1. Because remember, sine is opposite over hypotenuse, the opposite side of a triangle, whatever x minus y is in degrees or radians. It's going to be opposite over hypotenuse, sine of an angle, and opposite side is never more than the hypotenuse. So this always has to be less than or equal to 1. Never is going to be more than 1. If you get something more than 1, you probably made a computation error along the way. Okay, here we're going to have to calculate 3 different parts. Same kind of scenario. You got angle alpha in Q3. So if it's 4 over 5 for the tangent, that's negative 4, and that's negative 5. So this is root 41. And then this is quadrant 2 for the other triangle. So that will be 3 for the opposite side, 4 for the hypotenuse. So it'll be root 7, negative root 7, mind you. Working these out, sine alpha times cosine beta plus cosine alpha times sine beta. This one's going to be cos alpha times sine beta. Sorry, times cosine beta. Good thing that if these forms are provided for you so that you don't have to memorize. Minus sine alpha times sine beta. And lastly, this one here is going to be tangent alpha plus tangent beta over 1 minus tan alpha times tan beta. Now, remember, this is for alpha, and that's for beta. So sine alpha, that's easy. That's negative 4 over root 41. Cos beta is negative root 7 over 4. Then cosine alpha, and I didn't really show that very well. Cosine alpha is negative 5 root 41. And sine beta is 3/4. So you get 4 root 7 minus 15 all over 4 root 41. And as I said earlier with number 8, you don't want your answers to be greater than 1, but also you don't want them to be less than negative 1. So it's always going to be less than or equal to negative 1. So you have 4 root 7 minus 15 over that. Next up, cosine alpha, which we already know is -5 over root 41. Cosine beta, which we know is -√7 over root 41. Sorry, over 4. Minus sine alpha, which is -4 over root 41. And sine beta, which I know is 3/4. Minus negative becomes a positive, and you have two negatives, -5 and -√7. So I'm getting, I'll do it down below here, change colors for contrast. So it's 5√7 plus 12 over 4 root 41. And just make sure I've done this right. 5√7 plus 12 and 4 root 41. Yep. Actually comes really close to 1, but it's not bigger than 1, which is good. In fact, I get yeah, 0.985. So we're good. Then lastly, for part C, you have tangent alpha plus tangent beta. So you have 4/5 plus 3 over, or -3 over root 7, all over 1 minus 4/5 times -3 over root 7. And I'd probably leave it like that. I probably wouldn't simplify anymore, because you could really kind of really go down the rabbit hole if you decide to simplify, then all of a sudden you rationalize the denominator, you combine the fractions, it gets a little messy after a while, but that's totally good. So it's a lot of just plugging into the formulas. For 10, now double angles, sine 2 alpha, if you ever have a hard time deriving it, I mean a hard time remembering it, you could derive it from this. It's sine alpha times cosine alpha plus cosine alpha times sine alpha. So you wind up just getting 2 sine alpha cosine alpha because it's repeated. Cosine 2 alpha can be expressed actually 3 ways. You can use cosine squared alpha minus sine squared alpha, or you can do the Pythagorean trig identities and say it's 2 cosine squared alpha minus 1, or 1 minus 2 sine squared alpha. It's up to you. And in here, it's like saying tan alpha plus tan alpha over 1 minus tan squared alpha, or tan alpha times tan alpha. So it's 2 tan alpha over 1 minus tan squared alpha. Now, you do have this, and it's in quadrant 4. Here's Q4, -3, 5, and 4. Tangent alpha, that's obviously going to be -3/4. Sorry, let's do this one. Sine alpha, which I know is -3/5. Cosine alpha, which I know is 4/5. So you get -24 over 25. Here, if you do the first form of that, you get 4/5 squared minus -3/5 squared. 16 over 25 minus 9 over 25, you get 7 out of 25. And then for the tangent, you have 2 tan alpha, so it's 2 times -3/4 over 1 minus tan squared, which is going to be -3/4 squared. So you get -3/2 over 1 minus 9/16. So -3/2 over 7/16. If you flip things over, you get -3/2 times 16 over 7. That crosses out. So you get -24 over 7. And tangent could be less than or bigger than, less than -1 or bigger than 1, because It's opposite or adjacent, so the legs could really be in any ratio, it doesn't matter. It's just that you can't have an opposite or adjacent side more than the hypotenuse. So that's number 10. Okay, so these problems should be faster because you're not having to resort to these formulas that we did for the identities or the problems where you're given information about what angles in what quadrant and trying to find all these like sum formulas or difference formulas or double angle formulas. So this one's pretty straightforward, and you have to find all solutions. So it's going to be a general solution. X is going to be the inverse sine of 1, which I know is going to happen at pi over 2, and nowhere else in the first in the unit circle from 0 to 360 or 0 to 2 pi. And usually we like to give the answer in radians, but because it's finding all solutions, I mean, you could go around the circle once and then stop at pi over 2. So that's why we're going to write plus 2n pi, where n could be any integer. And because n is any integer, n could also be negative. So you can go around the other direction and go clockwise. Some people use the letter k, like some people say pi over 2 plus 2k pi. Just very clear that you establish what the constant's representing, like it's any integer, and you're all good. Take a look at 15. Sorry, number 12. You have 2 sine x equals root 3. Sine x equals root 3 over 2. Now that happens in 2 quadrants, in Q1 and Q4. Sorry, Q1 and Q2. That's going to happen, I believe, at pi over 3 and 2 pi over 3. And you put plus 2n pi next to each one. That's all. Here again, you want to isolate the trig function. So I'm going to add 1 to both sides, which actually does cancel. Divide by 6. Cosine x equals root 2 over 2. That's in Q1 and Q4. So that's going to be at 45 degrees or pi over 4 and 7 pi over 4. And of course, you add 2n pi. Tan x equals negative root 3 over 3. I believe that's going to be Q's 2 and 4. Who's negative. And that's going to happen at 30 degrees because then you're doing 1/2 over root 3 over 2, or something like 30 degrees is a reference angle. So we're going to say 5 pi over 6 and 11 pi over 6. Because remember, on the unit circle, when you're at 5 pi over 6, the coordinates are going to be negative root 3 over 2 and 1/2. And we do y over x, because that's what tangent is. You get negative 1 over root 3. And if I rationalize the denominator, I do get negative root 3 over 3. Now you could write plus 2n pi, and you're okay. Or you could write 5 pi over 6 plus n pi, because it is going around 180. So you could write that too. Either is acceptable. Sometimes textbooks will do the one you see on the bottom, but doing both angles plus 2n pi is totally fine. Now here you are asked to solve in a specific interval from 0 to 2 pi. And this will involve some factoring. So think of it as like a squared plus 2a plus 1, where a equals cos x. Use that as a bridge. If you factor, not too bad. A plus 1, a plus 1. So you have two factors that are identical. So a has to equal negative 1, or cos x has to equal negative 1. Here, you can factor out sine x. So you get sine x plus 1 equals 0. I didn't have to use the letter a. And so sine x equals 0, or sine x equals negative 1. Before I do the other two, let's finish off 15. So where's cosine going to be negative 1? I know that's going to happen at pi. And that's it. Here I know this is going to happen at 0. Also at 2 pi, but 2 pi is not included. So you have the interval notation there. So that's not included. And here, x is going to equal at 3 pi over 2. Sine x equals -1 at 3 pi over 2. 17, 18. So you're going to square root both sides. We got to put plus or minus, so plus or minus 1/2. So that's going to happen in 4 places. I know sine is 1/2 in the first and second quadrants, and then -1/2 in the third and fourth. So that's going to be at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So we'll have just unicircle, an extension of unicircle. So everything builds upon itself, right? I don't see how that problem is different. 18 is the same as 17. That's funny. If it were, say, cosine squared x, let's say, and cos x equals plus or minus 1/2, then that would be, of course, at pi over 3. 2 pi over 3 where it's -1/2. 4 pi over 3 is also -1/2, and 5 pi over 3 back to positive 1/2. If the question had asked that. Yeah, a little surprised that that got repeated. That's a typo. And the last 2 problems. You have to verify. I would actually work on the left side, even though the right side looks more complex, and write it as, and I kind of showed this earlier in this video, where you write it as a theta plus theta as a sum formula. So sine theta times cos theta plus cos theta times sine theta, where you can kind of think as the first theta as like letter A and the second theta as letter B. And remember, sine A, cos B, cos A, sine B. But so obviously you get both identical expressions, which you can combine like this. 2 sine theta times cos theta, or you would write 2 cos theta times sine theta, same thing. And then do the same thing here. You do cos theta plus theta equals the other side. So that's cos theta, oops, times another cos theta minus sine theta times another sine theta. And remember, we multiply 2 trig functions, you can write it as squared. Cosine squared theta, remember, that's not cosine theta squared. It's not that. That means that you're just squaring the cosine theta as a whole. Like that. Minus sine squared theta. And there you go. It's verified. Okay, that concludes the video.